Hello and welcome everyone to today's Pi Day celebration. Thank you for joining us. My name is Tara Van Cleve and I'm a marketing event manager for the Developer Initiative here at Oracle. Today we're excited to set up a WordPress service in containers on OCI Ampere A1 compute in the same amount of time that it takes to bake a pie. If you do not currently have an Oracle Cloud account, we've got a special promotion with extra credits so that you can try out OCI services and follow along with the hands-on labs today. To access the promo, please sign up using the same email address that you registered with for today's event. We'll also be recording the session and you'll receive a link to the recording within the next couple of days at the email that you registered with as well. If you have any questions during the webinar, we've set up a channel in our developer public Slack called Pi Day 2023 that you can access at the QR code here or at bit.ly/odevrel_Slack. Once you're in, you'll land in the general channel first, and from there you can search for the webinar channel. We will also be looking at the Zoom chat and the Zoom Q&A areas, and we will go live for Q&A after the workshops conclude. Today's webinar will be presented by Bhakti Hinduja, Senior Principal Applications Engineer from Ampere Computing, and Eli Schilling, Senior Principal Developer Advocate and Head of Tech Content at Oracle. So without further ado, I will hand it over to Eli.
Welcome everybody, happy Pi Day. Before we dive right in here, just thought I'd share some fun facts. Pi Day, the first celebration of Pi Day, 1988, physicist Larry Shah proposed we geek out a little bit and celebrate some interesting mathematics. It actually became a US holiday in 2009 when Congress decided to codify the day as a national, quasi-official holiday. And just so everyone else is aware, it happens to be Einstein's birthday too. So a lot of fun math stuff going on today. So let's get into the technical stuff and see if we can have a little bit of fun today. We are, of course, partnered here with our friends over at Ampere. I did want to spend just a couple of minutes chatting about some of the tasty goodness that comes from the ARM-based processors. As many of you probably know, ARM has been around for a little while. We've got over 180 billion with a B ARM processors out there in things like cell phones, IoT devices, and whatnot. And thanks to the amazing engineering teams at Ampere, they've been able to evolve those processors to become capable of hyperscale and cloud compute capabilities. So we'll be digging into some of the other benefits that come along with using ARM processors in the cloud. One of the interesting things that I always like to kind of point out is the scalability, ultra scalability with Altra processors. So depending upon what kind of toppings you like on your pie, you have the ability to kind of pick and choose how much, how many compute cores, how much memory, all flexible, all easy to use and deploy. And we're going to go through that process here a bit today. And of course, with the always free tier in Oracle Cloud, you do get 4 of those ARM OCPUs with 24 gigs of RAM, as it says there, always free. All right. So in the Oracle Cloud, if you're new to our ecosystem, you'll find a lot of really interesting and useful developer tools, pretty broad, diverse ecosystem. We're going to be tinkering a little bit today with Terraform and the OCI Cloud Shell. These are integrated into the Oracle Cloud Platform as native toolkits. We're going to deploy our lab environment on a compute resource, of course, running that Ampere A1 chipset inside of a virtual cloud network in OCI. And for future consideration, there are additional container native applications like managed Kubernetes, container instances, container registry for storing private image repositories, and a lot more. So beyond the workshop today, if you wanted to go tinker a little bit more, maybe take those containers that we deploy, move them out to Kubernetes or container instances, there's a lot of opportunity to kind of expand on the footprint that we're going to dig into today. The deployment options, I'll jump here in just a minute and also share a link to the workshop instructions, but there's going to be 3 options for deploying that virtual cloud network and compute resource. You can, of course, log into your cloud console, navigate to virtual cloud networks and then to compute instances and deploy the resources manually. The user interface is really simple, easy to use, and you'll be up and running in just a couple of minutes. If you're curious about infrastructure as code, we've built some Terraform that you can just take and run in Resource Manager. A couple of clicks of the button, and you will be up and running with all the resources you need. And if you want to tinker with the command line interface a little bit, the CLI, you can pop open the Cloud Shell right there in the console, take the instruction set that we provided for you, and run all of the necessary CLI commands to spin up your infrastructure that way. So I'll share that link here so that you can follow along and take a minute as I demo here to kind of pick and choose which route you may go to stand up your infrastructure. So here we have the QR code top right for the tutorial that will take you out to a GitHub page with all the instructions you'll need. The Slack channel there, we've put some links in the chat, but you can also just scan the QR code and join us on Slack. There's a Pi Day channel if you have any questions about the activities going on or just want to continue the conversation after we wrap up the session today. So let me jump over to my Cloud Console really quick. As I mentioned, you can very easily go through the UI. There is a VCN wizard that's going to ask you a couple of quick questions. I want a virtual cloud network with internet connectivity. We'll fire that off. It takes a couple of seconds and you're up and running with your virtual cloud network. We'll go into our compute resources and our instances. We'll stand up a compute resource here, deploying into that VCN that was previously created. Of course, we're going to pick the Ampere shape. And I always like to just pinpoint this a little bit because you can see if we're running a virtual machine, we can pick a single shape and then drag and drop depending upon how many resources we want. So it's really easy. There's no need to sort of memorize a variety of shapes. We just say, here's the one shape, 4 OCPUs and 128 gigabytes of RAM, and we would select the shape and deploy that resource. So for the workshop today, we're just going to use 24 gigs of RAM or less because the 24 point is the free amount. We'll select that and we would continue the configuration option. One thing to note, if you're deploying through the web UI, there's an option here to generate an SSH key pair that we'll use to log into our compute resource. So you want to make sure you save the private key. That way you can leverage your local SSH utility. If you're using Terraform or the CLI utility, you will need to generate a key pair or use a pre-existing key pair. So let me open up the Cloud Shell and I'll show a couple more things here before we move on to the next step. If we go into Developer Services, go into Resource Manager Stacks, this is going to be the infrastructure as code route that I mentioned. In the instruction set, you'll see all the fun stuff we're going to be doing, along with the 3 deployment options. So if you pick the Resource Manager option here, there is a download link that will grab the zip file. All of the Terraform files are also in this repository if you want to poke around with those later and see what we're doing to stand up the infrastructure. But for the sake of the ease of use, you'll just download the zip file and we'll import that into Resource Manager. So let me go create a stack. We're going to select a zip file. All right, so we've selected our zip file and it's going to read some information out of that zip file. There's a schema.yaml file that contains information about the workshop and the resources that we're going to be deploying, along with all the Terraform code. It also contains all of the pre-configured parameters. So you don't have to change anything if you don't want to. But of course, if you do want to change the name, the VCN CIDR, the amount of memory and CPU or cores that you deploy, you're welcome to do that here as well. I'm going to pause for just 1 second so I can safely paste my SSH key in. Again, just for security reasons, even though it's a public key, I'd prefer to keep it private. All right, so I'm going to paste that key in there, go to the next screen, and I'll resume my screen sharing here. So you'll see all the information about what we're going to be deploying. Of course, my SSH key that I added there. And the last thing we want to do is run apply and hit create. So Resource Manager will take all of the Terraform configuration. Everything is declarative. So we've defined what our network resources look like, our compute resources, and it'll take just a couple of minutes. We can monitor the logs here as it creates those resources. Now, just one more thing before we move forward here. I'm going to go back to the CLI option if anybody wants to try that route. And again, these instructions will be out here for quite some time, so you can always feel free to check it out later today, tomorrow, next week, etc. But you'll notice in the CLI here, we basically have everything set up for you. All you really have to do is copy and paste, run all the commands here. It's going to generate that SSH key for you with the defaults. It's going to place it in the .ssh folder inside of your Cloud Shell, so you can simply grab that when you create the compute resource at the end here. If you run the CLI portion, the last step, or second to last step rather, it is going to create the compute resource. Once it's done deploying, it will go and locate the public IP address, and it will return the public IP address to your command terminal on the screen. From there, you can SSH right out of the Cloud Shell, and you are inside the compute resource ready to rock and roll into the next part of the workshop. Well, without further ado, then, I'm going to pass it over to my friend and colleague Bhakti over at Ampere, and she's going to take us through the application deployment portion of this workshop. Bhakti, off to you.
Hey, hi everyone. Thanks, Ellie. Hi everyone. So today we're going to do a quick tour of what's involved in creating your own web application. So in this example and tutorial, we're going to use WordPress for our web application creation. And essentially, we're going to take a monolithic application and a monolithic way of deploying WordPress, and we're going to create distributed containers and make that monolithic application a cloud-native application. We're going to do and we're going to do this in the time it takes to make a pie. So it's going to be a pretty quick demonstration and tutorial. We have GitHub links in chat and over Slack. So please follow through the GitHub tutorial. If you have any questions, please ask it on our several forums, the Zoom chat or Slack channel. I'll try to keep the tutorial medium-paced. All right. So before we start the hands-on tutorial, I'm going to walk us through a small presentation to describe our cloud-native deployment today. So this is what our agenda looks like for the day. It's Pi Day, so we cannot start without talking about the importance and significance of Pi in our world around. We will also talk about what cloud-native applications mean. We will be using Docker and Docker-related utilities in this tutorial, so we will talk a little bit about those utilities. And right after that, we will start we'll get started with our deployment. In this deployment, we're going to have about 6 containers at the end of it. I'll walk you through those as we start deploying each container. We will also have a small performance optimization towards the end of our tutorial, which is going to be to use Redis as a caching database to our SQL database, MySQL, which is going to be in the backend. And lastly, this is just the start of your cloud native journey. So we're going to even talk about things that you can do as follow-up steps to our current deployment. So like I said, today's Pi Day. I have come across several occurrences of Pi, but there are a couple of those that have been very surprising and interesting to me. One of them is e to the power square root of 163 times pi is almost an integer. It is not quite, but it's almost an integer. It is a transcendental number, which is very, very close to being an integer. I won't go into the math of this, but this is also used to quickly calculate many digits of pi. And it has been worked on by several field medalists and mathematicians, and has been a very interesting discovery in the journey of mathematics. So I will encourage you all to go and read about this number and understand its significance. The next occurrence of pi that was very interesting to me was when it occurred that the probability of 2 random positive integers that are relatively prime, and relatively prime numbers are those numbers whose GCD is 1, is 6 divided by pi square. This is also a very surprising occurrence, how pi occurs in this calculation of probability. For those who are familiar with the field of mathematics, will also remember 6 divided by pi square in another context, which is related to the Basel problem. Where the inverse square of integers going from 1 to infinity is pi squared by 6. So this is another occurrence of pi, which is very surprising and interesting. I'll ask you guys to go read more about it. All right. So what is cloud native? To us, cloud native really is applications born in the cloud, right? They require very minimal machine management. In the case of traditional applications, client-server deployments or others, there was a significant amount of machine management that was involved, where you had to create server nodes and client nodes, other than writing code for it and deploying your software on it. So machine configuration was a key part of your deployment. If we look through the history of cloud, of computing in general, in the 1960s, we started with mainframe computing, mostly pieces of hardware and computers, which required very specific software that was specifically written to program those pieces of hardware. So very specialized software that was just written to operate a piece of hardware. It was not a general purpose piece of software that could be deployed on other pieces of hardware. As we moved to the decade of 1980s and beyond, we shifted to client-server model of computing, where we had PCs as well as servers. So we had software that could run on a client system, connecting to a server system. And both these softwares were relatively general in each of its scope. But again, the client piece of the software had to be configured differently than the server piece of the software. And most importantly, this involved a lot of machine management, like managing servers, managing clusters of servers, and so on and so forth. As the scale of our deployments increased, our scale of our users increased, our data scale increased, there was a need to have this software deployment in a more distributed manner. And that's where we reached the point of cloud computing. Now, in this decade of cloud computing, we are really looking at applications that can scale to multiple nodes seamlessly. So elasticity is a very important component of cloud native applications. You want to essentially spend less time in trying to scale your software, either from a hardware machine standpoint, you want the infrastructure to take care of it, or even from a software perspective, you want to spend less time in writing the scaling piece of the software, and want it to be very efficient in terms of scaling. So each of these decades of computing required specific hardware that had to be designed to meet its need. In the case of specialized software, there were mainframe computers. For client server, we know there were PCs and servers. Now, in the case of cloud, with cloud native applications, it is important that we also design systems, cores specific to these needs. So what are some of the challenges that we face when we run cloud native workloads and try to scale them to multiple nodes? So one important point in that deployment is predictable performance. Just because we are scaling our software to serve multiple users, we don't want to lose on predictability of each of our software deployment or containers or whatever infrastructure we're using to deploy software. So predictability of each software node is very important. And this is where Ampere Ultra processors, which is running inside of Oracle OCI A1 instance, comes in. We have a single core. We don't use hyper-threading or multi-threading like legacy processors do. And because of that, we are able to give predictable performance, not just high, but predictable performance for these cloud-native applications. We also have a lower latency and a larger private caches, which means that your containers can run independently without getting affected by the other containers running on the same system besides it, right? Last but definitely not the least, Ampere cores are extremely power efficient. And this is a very important constraint in going forward in cloud native applications deployment, because it relates to creating more data centers. And in order to meet our compute needs, we need to ensure that our data centers can be scaled sustainably. And that's where power efficiency is very important. So this is what is the benefit of using Ampere Altra as your processor for your cloud native applications. And this demo is going to use Oracle OCI A1 instance, which is running on the Ampere, which uses Ampere Altra cores. We have used Oracle Linux 8. So as I walk you through the deployment, I'm going to use a VM that is a 4 OCPU VM running Oracle Linux 8. And most of our scripts and code snippets are going to assume that you have this infrastructure. So if you have not signed up for the free instance program, please go ahead and sign up for the program. If you are unable to sign up yet, like I said, you can always follow on this tutorial at a later point as well. All right, so without further ado, I'm going to walk us over what our current deployment is going to look like. So we're going to deploy a cloud native web service. We're going to have a client which is connecting to a load balancer. And that load balancer is going to have multiple microservice containers interacting with it over a gateway. And those microservice containers are going to communicate with each other using message queues and are also going to be connected to a backend database. So in this case of deployment, we're going to be using MySQL as our backend database. We are going to be using WordPress as our microservice containers and nginx as our proxy. Like I said, this is all running in OCI A1 instance. We are also going to use Redis as a caching database to our MySQL database to be able to retrieve previously accessed data faster. So without further ado, I'm going to quickly switch to my terminal window and we shall start the deployment. All right. So the first step of this deployment is going to be to install Docker and its related components. So this is a relatively time-consuming process if it is done for the first time. So I have already completed the Docker install steps on this VM. Which can be found in the GitHub tutorial. So it just basically adds the Docker CE repo using yum config manager, and then installs Docker CLI, and other utilities that are going to be needed for this deployment. All right. Now, as soon as we complete that, we're going to start and enable Docker. So systemctl start Docker and enable Docker. So this has enabled the Docker service in our VM. Now, in order to run Docker as sudo, we're going to add Docker. We are going to give Docker a user super user privileges. So and now we should be able to operate Docker as a sudo user. For this to take effect, we will have to exit out of our shell script or even restart your VM, whatever suits, whatever is suitable. So now we are going to quickly check if Docker is installed and has sudo privileges. So we can see Docker along with OPC and other users created, which tells us that it can run as a super user. We're going to quickly run a hello world using Docker. So this is essentially pulling a hello world image and displaying the message, ensuring that your Docker is working fine. It's able to pull images as asked from Docker Hub. As you will also see that since this is running Oracle Linux on an Ampere Ultra core, it's pulling ARM64 images as expected. So you're going to be pulling multiple of such ARM64 images from Docker Hub in our entire deployment. All right. Now, we're also going to enable Docker Compose as a part of setting up our infrastructure. Docker Compose can be downloaded from its release page. We have linked that in the GitHub tutorial. Currently, I'm using 2.16 as the version, but like I would recommend you to get the latest one if you happen to follow this tutorial after a few months. As any software, Docker Compose will have any bug fixes and newer versions available in its release page. All right. So now that we have installed Docker side of utilities, we're going to just install Git and then clone our PyDay tutorial repo and start our first container deployment. All right. So we have successfully cloned our PyDay tutorial video, and if you are not followed until this point, you can go and follow these instructions from our GitHub tutorial as well. All right. So now we're going to start our first part of deployment. Like I said, we have this deployment in a 4-step process. Our first step is going to be to create a WordPress container and have a backend database, in this case, MySQL, connected to it. So as you see in this, as you see in the WordPress 1 folder, you will find a Docker Compose YAML file. This YAML file has description for the WordPress container as well as the database container. So essentially, it will set up the right username, host, password for the WordPress container. It will also ensure that the WordPress container is connected to your local host at port 80, which means it can listen to any requests coming from your client at port 80 through WordPress. This WordPress container is then going to be connected to a backend database MySQL container. So in the definition of the MySQL container, we have, again, its username, password, and several other details that, basic details that MySQL container would need for starting up. You can review these YAML files in our GitHub tutorial as well. All right, so before we start our Docker containers, we will create a MySQL database folder where it will store the database, the logs, and several other components required to start the MySQL database. And then we'll go to our WordPress 1 folder. Like I said, this already has the Docker Compose YAML with description to start 2 containers. The WordPress container listening to requests at port 80 and the MySQL container, which is a backend to this WordPress container. All right, so we will use Docker Compose utility tool to start these containers. And the first time that these containers are coming up, it's going to take some time because it's going to pull images from Docker Hub. In your subsequent deployments, these images will be cached, and it will be faster to bring up your containers. Like I also said, we are using port 80. in this deployment. So we need to make sure that that port is enabled in any firewall setting that your VM has. This is very easy to do on OCI. And one of the benefits of using OCI for your cloud native deployments, you can enable port 80 in your VCN settings for your VM, and it should be able to accept connections at that port. All right, awesome. So we have successfully deployed 2 containers, a WordPress container and a MySQL container. Now we're going to list those containers to see how our deployment looks like. So we're going to use Docker Compose PS. This will list containers, so we can see that we're running MySQL 8 in our MySQL container and 6.1 Apache in our WordPress container. All right. Now I will just move my screen over to my WordPress admin screen and walk you over through that and show you how this looks at the back end in WordPress and how you can launch your first website with just 2 containers in a very short time. So I've opened up WordPress over the IP, which is the external IP of my OCI VM. And this is this is listening at port 80 for any incoming connections. So I'm going to open the WordPress admin page, and as I see, there is an install page that's letting me choose the language of my choice. So I'm going to select the language of my choice, and then just add basic details like your site name, your username, and your password. In the case of password, I'm going to use the value of pi that I recollect to my best knowledge, and and then just input your email ID and install WordPress. All right, so you can log in to WordPress using the login credentials you use to install WordPress. And this is how your WordPress admin page looks like. This is going to be of most use at the end of the deployment, where we are going to enable caching to make your WordPress application faster. But I just wanted to show you how it looks and in the front end, and how do the 2 containers really show up in your application. All right. So we're going to move to the next part of our tutorial. So that's going to be the second part of our tutorial, where we're going to use nginx as a proxy to our current deployment. So our current deployment used a WordPress container and a backend MySQL container to host the application. Now we're going to create an nginx container, which is going to act as a proxy to the WordPress container. So essentially, the port mapping of 80 that happened at the point of your WordPress container is now going to switch to your nginx container, which is going to listen at port 80 to any incoming requests, and the WordPress container is going to be shielded from any incoming requests. So so it's going to act as a proxy and going to shield your application from the front-end user. All right, so I'm going to share my terminal screen again and walk us over the next part of the deployment. So I have brought down my containers in my previous deployment because we're going to change a few things in the Docker Compose YAML file, and we're going to start an nginx container along with our WordPress and MySQL containers. So if you look at this Docker compose YAML file in the WordPress 2 folder, you will see that there is an nginx container, which is the latest nginx image from Docker Hub, essentially listening at port 80. And this nginx image is connected to the WordPress image, which is using MySQL as a backend database. Now, before we start MySQL, we're going to add our IP as the listening IP in the SQL file of the MySQL database, so that it's listening for connections at the right IP. So for this purpose, we go to our MySQL folder, and essentially we are going to set or edit our IP, existing IP with the IP of this system. So my IP is 141.148.159 and 174. All right. So I'm going to add this IP in a PyDay SQL file, which is going to ensure that MySQL is listening for connection requests at this particular IP address. And from there, I'm going to go back to my WordPress 2 folder, and I'm going to start my containers. In this case, we're going to have 3 containers coming up, as opposed to our previous deployment, which started 2 containers. And as you see here, the images are cached already from Docker Hub, so the deployment is going to be much faster. What this is really waiting for is a health check from the database side. So MySQL is doing a health check right now to ensure that the database comes up as expected. And only if that is passed will the WordPress container start. This is to ensure that the database database has integrity components fulfilled with its deployment, right? So you want to make sure that your data is correct in its most updated form as well before you start WordPress. So that's what this health check is really doing. All right. So now we're going to run Docker compose ps to look at our container deployment. And we have 3 containers now deployed. So it's the MySQL container, which is a database, nginx acting as a proxy to our WordPress container. So you have created a cloud native application with the 3 container deployment in no time. All right. So I'm going to bring down these containers, and we're going to move ahead with the next part of our deployment. So the next part of our deployment is my favorite part. So it's really taking this application and exercising its cloud native muscle, right? So what we're going to do is we're going to take our 1 WordPress container and we're going to scale it to 3 containers. In this case, we're using 3 containers. You can use n number of containers very seamlessly. What it's going to do is it's going to give your deployment the ability to scale microservices. And in case you have a more number of users who need to connect to more containers and you need to serve faster, this is a very easy way to do it. So in our Docker Compose YAML, we have 3 WordPress containers now. Each of those are copies of each other. So they are exact copies of each other. So no extra code involved there. Very seamless scaling. We use nginx now not only as a proxy, but also as a load balancer. So this is another property of nginx, which is very popular. So essentially, you can use nginx to balance load going to your 3 WordPress containers equally. Typically, the base logic to load balancing is a round robin. So it will send each request to each container sequentially. You can also do this for testing purposes. So if you have a canary cluster versus a production cluster, you can make sure that some requests, maybe 5% of your requests are going to the canary cluster for testing purposes, and then 95% of those are being handled by your production cluster. So there are several avenues you could explore with load balancing and scaling containers for any kind of deployment. All right. So now we're going to go to our third WordPress folder. And like I explained, the Docker Compose YAML here consists of definitions of nginx as a proxy and a load balancer, and 3 WordPress containers and a MySQL database. All right. So since we have covered what this deployment looks like, I'm going to quickly go and start the containers. And like I explained previously, the database is ensuring a health check here, and only after that, the WordPress containers will start. Now, there are several things you can even do with the MySQL database, right? You can keep backing up from time to time and restoring from your recent backups. This ensures that you're starting your database with the most latest restored data at any downtime. And it's also a healthy practice to ensure that your data is still restored in a secure backup in case the deployment is affected for any reason. All right, so the MySQL container has started, and so have the WordPress containers after the health check passed. So now you have 5 containers running, and we're going to quickly view them. Yeah, so this is the database container running MySQL in the backend, nginx running as a proxy and a load balancer, and 3 WordPress containers to scale application load. So technically, this is a pretty neat cloud native deployment in itself. We could be done here, but we have a small bonus for you. We're going to try a performance optimization on this deployment. So we're going to add Redis as a cache to this deployment, and it's going to help retrieve requests faster from a MySQL database in case of high load. So let me first bring down these containers, and then we can move to our final step, which is going to be using Redis as a cache. So if you're following me up until this point and the GitHub tutorial, we are going to be going to the last part of our demo, which is the WordPress 4 folder. And this is more like a performance optimization, and it's not a necessary part of your deployment, but a good to have part. All right. So we're going to start our Docker containers. So as you see, it is also pulling up Redis images from Docker Hub, along with the other images that we've previously used. And as always, it's waiting on the database to complete a health check before the 3 WordPress containers are started. Now, once we start these containers, we're going to go and make a small change to a WordPress config file to enable Redis host and port so that we can add that plugin feature to our WordPress application. And I'm going to walk you over that right now, but we also have this documented in our tutorial. So feel free to go look at it in order to change this file setting. So we're going to go and open the WordPress admin, the WordPress config PHP file. You need to do this as a sudo user. And we're going to add a couple of statements, really a very small change to this file to ensure that WordPress can interact with Redis. So although we have started the Redis container, we have ensured that our containers can talk to each other. It is important to configure WordPress also to communicate with Redis, because Redis is going to be used as a caching service by the WordPress containers in case the data is found there, and it's not going to have to go to the MySQL database every time. All right, so these are the two definitions that you need to add in the WordPress config file, the Redis host and the port. Awesome. Now we switch back to our WordPress admin page, which we had briefly looked at the start, and we're going to continue our deployment there. So I'm going to log in with the credentials I had used to install WordPress. I'm going to go to plugins, add a new plugin, and I'm going to look for the Redis cache plugin. I'm going to click install. And I'm also going to try to activate it. So since we have already configured Redis in our WordPress config PHP file, we should be able to enable it from here. So it's connected and enabled for the WordPress application to go through Redis if caching requirements are met. All right. Now, we're going to also do one more optimization, which is related to caching web pages. So while Redis is going to act as a database cache, we also want to cache web pages so that if a web page is requested again by some authenticated users, we should be able to quickly find it through our cache rather than going through the logic of looking it up in any of our databases. So for this purpose, WordPress has a cache, which is called as WordPress Super Cache. And we're going to install that cache for our application. And after installing, we're going to activate it. And I'm going to enable caching here, update status. And I'm going to quickly test my cache to see how it's working. All right, so I don't have any caching requests at this point, and you don't see a bunch of requests being cached because I have not tested my application with a front-end client. But when you do see in requests come in, you're going to see them being cached and retrieved from here. All right. So that brings us to the end of our deployment. But like I said, it's definitely not bringing us to the end of your cloud native journey. So I'm going to walk us over some next steps that you can do with this deployment. Covering over this deployment once again, we created nginx containers. Nginx acted as a proxy and then also as a load balancer. We scaled our WordPress microservice to 3 containers to be able to serve more load as needed. Nginx was trying to load balance between these 3 containers. These containers connected to MySQL as a backend database and also connected to Redis when any caching requirements were met. All right. So we're going to discuss what are our next steps from here, right? So we have not enabled something such as SSL or any kind of encryption mechanism. So that is a very important step for deploying WordPress-like applications or web applications and making sure that they are secure. We have also not enabled any ways to protect the website from malicious attacks. So these are definitely things that you can do for your web application. You can also try backing up and restoring MySQL database like I had described previously. You can add monitoring services, you can scale your load balancer, you can change the logic of load balancer, you can scale more number of WordPress containers, and you can do a lot more with this deployment. So I will really encourage you all to go ahead and explore more with this web application deployment that we did. Lastly, I want to leave you with some useful links and resources for Ampere developer, for our Ampere developer community. So we went over a web service deployment, but that is not the only kind of deployment that you can do with cloud native type of applications. You can have data services, video services, media services, and many more. So we have a lot of resources available on our developer briefs right here. They are workload briefs that talk on configuring workloads such as Redis, nginx, and many more. We also have a developer community which you can engage on with several developers, not just Ampere developers, but also ARM64 developers. And you can sign up, ask questions, answer questions, and just engage with the community there. We'll be sure to help you with any issues or bug fixes or bugs that you find on any of your deployments. We also have a bunch of tuning guides. These tuning guides talk over deploying workloads and solutions on cloud native like workloads and solutions on Ampere systems, and they will walk you through any specific tuning that the Ampere systems require and help you deploy and scale your application. So with this, I will pass the presentation back to Tara, and wishing you all a happy Pi Day, and I hope you enjoyed this tutorial.
Thank you, Bhakti, and thank you, Eli, for the fantastic presentation. If you'd like to test your knowledge on what you learned today, we do have a quiz here. So we do also have another special event coming up next week that will take place over 4 days, filled with expert-led talks, hands-on labs, and demos covering cloud native and AI services, Java, data strategies, and MySQL. So if you're interested in learning more, please go ahead and scan that QR code, and I will drop that in the chat in just a second as well. We are at time, so I just wanted to say thank you again, everyone, so much for joining us here today. We had a wonderful time celebrating this Pi Day with you, and we hope to see you again next time.